Hey guys, good morning. I strip this motor. This is a M6V rotation motor from 271 Epiroc machine. So I'm going to strip all. So I have my survey, so checklist. I made this from the scratch, so that's easy for me what to inspect once I've done the stripping. Control, it's on the A side, so that will be easy when I'm doing the assembly. Of course, you write the job number, the date. Since this is motor, the rotation I put is bi-rotational. So all details is here. So I stamped the housing. So I'm gonna take photo first to send to the customer how it arrives. So I normally separate the bolts and any, if there's a rusty or paint part, so I just put it here. Caps. So since this is blasted, this oil here I'm gonna use to rub on the housing so that the housing won't get rust. You can use CRC if you want. I just use this still oil, so because what happened is after I strip and then when I ordering the parts, there's a lead time, so the job will wait for a long time, so to avoid rusty, so need to lubricate. So these ports here are for the stroking command. So if you want min and max, so you want to change the displacement of the motor. So if you want to adjust it, so this one here, okay, so this is the max adjustment and this is the min adjustment, okay? So that's how you adjust the displacement of the motor. So if you want to increase the RPM, so you need decrease the displacement. If you want to lower the RPM, so you need to increase the displacement, because RPM is inversely proportional to your displacement or motor size, which is the cubic centimeter per revolution. So you're gonna remove all the seals, you know, the O-rings, because you have to replace, you need to replace that mandatory. This is the servo shaft. So the servo pressure past this gallery here. That's why you have O-ring here, so that it won't externally leak. So see this port here, this is where your servo pressure, okay, so this here is where you can This one, this is the servo port here, and the other side as well. This one, so you can check your servo pressure there. So you know that pipe, the tube, the bigger tube. Once I strip this, I will show you. That connect to the chamber cover. That's where your servo coming, and then through here, and then pass it this gallery inside the servo shaft, and then on the plate. You know, this plate, this shoe plate. Remember, there's a notch. The notch always face on the cover. Okay? The square one always face on the motor side. Otherwise, if you put that other way, then all your servo will go to the case, and then you notice your case flow rate increase, and then of course you're losing a servo control. Later, I'm going to assess this, check the bore clearance, make sure the clearance is good. Normally, 25 micron clearance is good, but beyond 30, then have to replace. I limit it to 30 microns. And then above that, then that's your max 30 micron. So otherwise you too much leakage. Losing this lock here, the indicator. By the way, you need to check this. Sometimes this one crack. I'm gonna take my morning tea, guys, so I'm gonna come back later, okay? Before you take the head in this type of variable motor Denison, you need to remove the nut first that hold the barrel hold down shaft. So I'm gonna remove the lock from the nut. This is how you adjust your preload, your barrel preload, or they call it hold down barrel. So this nut here, this screw on the auxiliary shaft, now you can remove the rest of the head bolt. I'm gonna remove the servo plates and the stem. So this one. This is a servo stem. See that? Drilling and ports, that's where your servo go. But because this side here is an indicator side, so it's blocked. It's sealed off. The control side is, that's where your servo pressure going in. So on the other side, so because see this one has no port, so it's just blocked there. But on the chamber, there's still a servo pressure there, so that balance left and right, right and left. So they just balance when the displacement change. Pushes that cradle or the cam. So I'm removing the servo plate on this side here. I need to remove the plug first, then remove the screw. There's a plug there, and then this one's smaller next to that size. So I'm removing the servo plate and the servo stem. Okay, servo plate where the servo shoe run. Let's see the servo shoe like that. Okay. Now remember this side here, the servo shoe is the square or the rectangle one, okay? So that's where the shoe doing, okay? So see that center there is that face is the ceiling. So meaning it's neutral, okay? So that hole the square hole that go through this gallery, and then went to your cam. In the cam there's a drilling, and then in that drilling passes to that drilling spring, lift the veins, and then went through check valve, and then to the chamber. Okay, I will show you once I strip. And remove the pins. Small tabs for the small parts. Done. Lens plate. Faceplate. This is always mandatory if the motor done many hours. It's worn because you try to lap this and get warped because it's so thin. And then sometimes the coating, the Teflon coating removes, so I normally replace that mandatory. Pins. Alright, so the gasket. barrel. This is the auxiliary shaft. Bearing plug. This one I need to remove the roll pin that hold the bearing actually. Barrel bearing. So this bearing here is to guide the barrel, to minimize the reaction force from the chamber. So obviously the barrel will be like that. Okay, so this hold that thing. It's a good design. So the barrel will stay as possible in the center axis because of that bearing. So now remember, you have a flat lens, and the disadvantage between the flat lens and the spherical lens is during the operation, the resultant force from the force of the chamber will cause the barrel, what's this? There's a term of that, off from the axis, and then what happened is will lose your efficiency because it's a flat lens. It won't, what's this? It won't follow, unlike the spherical, it follow because the concave and the convex of the shape. So exaggeratedly, okay, so you have pressure in the chamber, piston chamber. Of course, the resultant force that make the barrel off from the center go like that, and what happened is the lens, you know, see, instead of the gap is like that and go like that, so you lose that efficiency. Now this one here is to prevent that happen, to stay in the barrel on the center of the axis. Yep, so you notice on the efficiency graph between the normal flat lens type and barrel compared to the spherical type. The spherical type is up to 98% efficiency, unlike the flat lens is around between 90 to 94. So yeah, that's the disadvantage of the flat lenses type. Now the center housing done, so I strip all the parts. Now this one here is the servo tube. This one here is the high pressure tube. So this is that's one there is to lift the cam to the cradle. You have that hydrodynamic lift. So yep. So I'm gonna remove the pistons. I'm gonna take the circlip out first. See, that's on the max position. I'm gonna put the neutral angle. This is a bit tricky, I think, because my circuit plier is getting worn. It's good. Thrust washer. So see this cut here. I normally check that if it's worn. If there's a worn, then I'm gonna replace it. That's the reason this one turned, because of that worn. So this is the chamber cover. This is the servo tube. This is the chamber, the can, and the cradle. So the servo is supplied externally, and there's a pressure reducing, so that control pressure will go to the servo pressure servo gallery. This is the chamber, guys. These are the vanes. This is for sealing. Check valve. This is check valve, guys. Shuttle. these round parts here. This is your shuttle. So this thickness is smaller than this one. Servo control pass on this, like there's a slotted here, of course, through that hole. This is a servo. You can put gauges there, or you can use that as a control. That's because of this tube. So strip everything, then later on I'm gonna assess. I'm gonna measure the piston barrel clearances, thickness of the plate, if it is in the spec, then the condition of the other parts. There's a bowl here, bowls here, guys, so just be careful when you remove that seal. So that is my replaced parts. Obviously the shaft is heavily worn, so no need to remove the bearing. But yeah, that's all the parts. So I need to remove that spring from the barrel. So that's easy. You just press it and then remove that retainer ring. So that's all, guys. I'm going to do my survey and then go from there. So what I'm doing is I'm measuring the pocket, or other term is the height from the land. So from this face to the land face, that's the height. So, or pocket. make sure that it's still in the spec. Otherwise, when you after the lapping, then might be too much, you know, it's thin and then cause a problem on the operation because there's no balance anymore because the land is too thin. Remember that first land is the ceiling, that's where the high pressure is. So see this guys, not sure if you can hear that, but I will so there's a click, that's the shoe float. Alright, so these 2, 4, 5 here pistons are too much float, but I'm not sure if it is too much or not. So I'm gonna measure it. If it is out of the spec, then I'm gonna replace the piston. Okay? So very important to measure the shoe float. Otherwise, if it is out of spec, then this will come out from the skirt. Remember in my last video, I explained that to you, the reason. So there I have my jig. I show you guys what happened if you're reusing pistons with a high show float. So see this one here. See that inside the shoe? That's because of the hammering of the ball, because the float is too much, and then this will come up during operation when the float is too much. Okay, so that's what happened. That's the condition of the shoe. Let's focus. See? No good. So eventually it will come off, and then causing a problem. So to prevent that, you have to measure proper. Use a dial indicator so that you know how much the float is. Take time on the assessing the parts. Make the right job at first. So make the job right at first before it's too late, you know. So even that noise, so still okay, this one here. So I limit my shoe flow to 0.2 or 200 microns. So you have to push that way and then 0 and then pull and push. So that one is 0.08, so 80 micron, so it's good. Alright, so each graduation is 10 micron because it's 0.01. So 0.08 so far is my float. Let's see this one here. So by the way guys, you can't buy individually of this piston, you have to buy the set. Point 0.07. This one. There's a nylon on the front of that steel so that you won't scratch the shoe face. So I'm confident that I can reuse my piston because it's only 0.08 or 80 micron float. So see, if you didn't have this, then you don't know if this is reused or not. This time I'm going to check the clearance or the variation at the same time. So clearance and variation. Make sure it's in the spec. Use a dial bore gauge. So you set your dial based on the diameter, the outside diameter of the skirt, and then you measure the inside bore or the bore. Then you can get the clearance. At the same time, you can read the variation. So far the clearance is good. So that's it guys for now. I will continue my assessing. I will not show you because it might get too long, but that's how I strip and assess the hydraulic component. So yeah,